Hello guys, welcome to this class. In this class we are going to be explaining what we call scalars and vectors quantity. Scalars and vector quantities. Scalars and vector quantities. So I would like you to understand that in physics there are two quantities that are very, very important. One is scalar quantity. One is scalar quantity, and the other one is what? Vector quantities. So let's talk about scalar quantities. Scalar quantity. What is a scalar quantity in physics? A scalar quantity in physics is a quantity that has magnitude. Are you getting it now? It's a quantity that has magnitude and no direction. No direction. Sorry. No direction. Make sure you write those things down. It's very important. It's a quantity that has magnitude and no direction. So which means that direction does not affect the magnitude, right? For example, now the length of a table, let's say the length of a table is 5 meters. That 5 meters is not dependent on the direction. So even though I take it to the sky, it remains 5 meters. If I take it to the left, it remains 5 meters. If I take it to the right, it remains 5 meters. So those kind of quantity in which direction do not affect their magnitude is called scalar quantity. Now, what is magnitude? Magnitude is the value. Magnitude what? Magnitude means the value of the quantity. It means the value of the quantity. Are you getting it now? For example, when we say the length of a table is 5 meters, this 5 is the magnitude. Are you getting it now? For example, now we say the speed of a car is 100 meters per second. That 100 meters per second is what? The magnitude. Are you getting it now? That is the value. So 100 meters per second is the magnitude. So those quantity in which it has magnitude but no direction are called what? Scalar quantity. Now let's go to vector quantity. But before we go to vector quantity, still on scalar, let's talk about examples of scalar quantity. Examples of scalar quantity. Examples of scalar quantity are length. I getting it now? Length, time in physics, O-level physics, distance, length, time, distance, mass. These are all examples of scalar quantity. Temperature. Temperature is an example. Temperature. Work is an example. Energy. Heat. These are all examples of scalar quantity. etc. So these are all examples of scalar quantity. Now before we go, let's talk about addition of scalar or arithmetic of scalar. Addition of scalars. Scalars are added using simple arithmetic method. You just plus them together. For example, let's say we have a system, example 1. Let's say we have a system where we have 1 kg, 2 kg, 3 kg, 4 kg. So if you want to add those scalars now, you don't need, they don't have direction, right? Because direction is not important in their magnitude. So we just add. That means that 1 plus 2, 2 plus 3 plus 4. So that will give you what? 1 plus 2, 3. 3 plus 3, that will be 6. 6 plus 4, that will be 10 kg. So you see how simple this is. But for when we get to vector, you discover that it will not be like this, because addition of vectors depend on the direction of the vectors. I get it now. Addition of vector quantities depend on the direction of the vector. So before that, let's talk about vector quantity. What are vector quantity? Do you want to know what are vector quantity? Don't worry, watch the next video, part 2. We'll be talking about vector quantity, but we are still on the topic scalars and vector quantity. So I want the video to be short so that it will be interesting and easy for you to understand. So watch part 2, vector quantity. God bless you.